I entered again an Excel sheet or Google Sheets, the data that was given from question 10. You just copy and paste this and put in Desmos. And then I get this data here. Ooh, we really need to zoom in here. So it looks like a quadratic. It looks like it's going up and coming back down, right? Change the scale and I got this. Yeah, it definitely looks like a parabola, right? So let's grab this data, okay? That looks like the vertex. Okay, so does the data look quadratic? The answer is definitely yes, right? So you can tell it's quadratic even without the graph by doing the following. Here, we find a finite difference between the y values. So let's take this one and subtract that one, okay? And we do that all the way down, okay? And then, so it's all different, and you just do that one more time. Okay, so we take, this is the first finite difference. It's different, which tells us it's not linear. But if you do that, subtract one more time, if these are all same, okay, if I fill this down, right, press Control D, and if it's all same, that verifies this is a quadratic. There you go. Okay, of course you could have done this by hand as well, right? All right. Back here, so you could have just done the calculation here, right, by hand, and show that it's right, it's a quadratic. So C, estimate the coordinate of the vertex. It'll be that. Determine the algebraic expression. It's going to be y is equal to ax minus 1.5 squared plus 16.25. Okay, so to find a, maybe we can grab 0 and 5. So 5 when x is 0. Okay, so it's 5 minus 16.25 all over, you got 1.5 squared. The negative disappears because if you square it, negative turns into positive. So a is minus 5. So the equation is minus 5, x minus 1.5 squared plus 16.25. Okay. Use your model to predict. So for E, when it's 2.575, that just means replace x with 2.75. Okay, find out what that is. And then at 1.25, replace x with 1.25. Okay, so let's evaluate these, okay? 8.44, 15.94 for the height in meters. How effective is your model for time values that are greater than 3.5? Well, like I think it's gonna hit the ground by then. So not very useful, right? The model is only valid until it hits the ground. If it goes time beyond that, it's useless basically, right? Okay, and then we have to check your answer using quadratic regression. Back in Desmos, this is how you do it. Y, 1, wiggly sign for, that's to activate the regression, okay? So let's do x 1 plus b plus c, okay? All right, so that's the equation that passed through all of that. Here it is. It's telling you a should be -5, which I have as -5. Right, it's actually perfectly accurate, right? My answer is perfectly accurate. Right, that means the data points here are perfectly fitting on a parabola.